Bienvenidos, Ushamdid, and welcome to this HUD 8 Consulting networking techtorial on Cisco's Enterprise Networking Security and Automation course, or ENSA, which is part of the CCNA version 7 curriculum. In this video, we're going to be focusing on Packet Tracer Activity 6.4.5, where we're now going to dig in and take a focused, closer look at how to configure Static NAT. So here is our topology on the left-hand side for this activity. You can see we've got a server, switch router, the internet connectivity, and then we've got laptop 1 and PC 1 out here as well. So the objectives, we're going to test access without NAT. We're going to We're going to configure static NAT, and then we're going to test access with NAT. Now remember, to get out onto the public internet, you need a publicly routable IP address, and this is typically not going to be the IP that you're using on your devices inside your house or your office or your enterprise, right? You're going to be doing some sort of NAT translation, a network address translation, translating the address from an RFC 1918 address to a publicly routable IP address. And we'll talk about those different ranges, and we're even going to talk a little bit about some of the reserved ranges we saw in a previous video, a 192.0.2, and that's actually defined in the RFC. So let's test access without NAT. And it wants us to switch over to simulation mode, which I'm going to go ahead and do here. And it says from PC1, and we've got PC1 up here, let's go ahead and try to connect with a web browser to the server 1 web page. And so we're going to say http:// we'll say 172.16.16.1, and we'll click go, and let's go ahead and do the simulation. And so you can see we've got this red packet with the flashing X here, right? Which is not good. And you can see that it comes back ICMP message type 3. If we were to click down here, switch 1, we can see that we get a second message, right? We can see the source IP is 10.0.37.1, and the destination IP is 10.0.37.205. So the destination, right, this is coming back to PC1. And so we have just these two packets that exist right there in terms of what it is that we were trying to do. When I click go, right, trying to get to that web page, we can't get there. And so you can see here, it says, notice how the packets never leave the internet cloud, right? We got the red packet came right back to us. From PC1 ping the router 1 interface. And so let's try to do that. We'll pull up the command prompt and we'll say ping 209.165.201.2. And it says that the ping should succeed. And maybe we've got a quick ARP and a request timeout, but then the subsequent packets should be successful. So we'll give it a second here. And actually, I'm sorry, play it out there. Whoops. And we'll play it out there. And you can see that there goes the packet, right? It kind of slowly plays out there. And you can see that the packet went out. And here are the different ICMP packets that are going out. And there is the information we're getting back. It says the ping should succeed. Interestingly enough, there we go. Finally, it's playing out for us there. We're getting the replies back. And while it's slow, it is working. So view R1 routing table. So we're going to jump out of this simulation mode back into real-time mode. Let's jump on router 1 here. And let's see what the routing table looks like on router 1. And so the first part of the activity, we were on PC1 trying to access the server over here coming across this internet cloud, right? And here is sort of like, think of this as the, company network, and maybe we've got a web server of some kind sitting there named server 1. Let's go from user exec to privilege exec, and we'll say show IP route. And wait, did it say the routing table? Or view the running config. Sorry, not the routing table. So we'll say show run. And they want us to come down and check to see if there's any commands for NAT. And clearly, there is not a lot configured on the router other than the interfaces, right? So they say do a show run and include NAT or INC NAT, and you can see we don't have any NAT commands configured. Verify the routing table does not contain entries referring to the IP addresses for PC1 and PC2. In other words, do we have any static routes configured on this router? And we don't. We're just showing the directly connected networks along with their associated local entries that are in the routing table. And then finally, we're going to say show IP NAT translation. So we've got nothing set up. Let's get static NAT configured here. And again, the key takeaway with static NAT is it is going to be in the translation table permanently until removed from the running configuration. And it is a strictly one-to-one relationship where the inside local IP is inextricably linked to the inside global IP. Now you'll notice I use the word inside there twice. Inside local, inside global. The inside local, from the perspective of server 1, is going to be the 172.16.16.1 IP address. That's its inside local RFC 1918 address. The inside global is how server 1 will be perceived from everyone on the other side of the NAT boundary, meaning this side, in the global context. So we're saying that this is the global world out here. So the inside global is server 1. Its inside global IP will be 64.150.1 because that is how everybody out here globally is going to see that server 1 address. And again, from the perspective of server 1, that's the inside local, that's the inside global right there. And let's go ahead, I'm going to leave the markings there, and we're going to run through the static NAT configuration. Static NAT is by and far the easiest of the NATs to configure because we aren't going to have an access list involved of any kind, right? Or subnetting of any kind that we're dealing with. We're simply doing a one-to-one IP NAT inside source static and then the inside local address 16.16.1, and how does it map to the inside global address? Those same values you see above listed as inside and outside. And now all we're going to do, excuse me, is we have to make sure that we indicate which interfaces will be performing NAT, right? So is it going to be IP NAT inside or IP NAT outside? So if you look here, they have us go to the gig 00 interface. If I was to go into int gig 00, 00, and let's first say do show run, and we can take a look at those interfaces. So there's the interface, the 172.16.16.14, and you can see we've got a subnet mask of 255, 255, 255, 240. In other words, a /28. And if I come a little bit further down here, I'm looking for that serial interface. And there's our serial interface, serial 000, that connects us to sort of the outside internet world. So let's go ahead now and let's type in here IP NAT inside, because this is the inside interface, right? This is the interface on the inside of the router that should be performing the NAT operation, right? And so we have to indicate which interface that is and what interface should be performing NAT. So I say IP NAT inside. Now it says configure the serial 000 public interface as an outside interface. So we go into, and this is a command that they don't give you, but if you know IP NAT inside, you should know IP NAT outside, right? Pretty straightforward. And we need both of those commands. It will not work if we're missing the IP NAT outside command on the outside interface, because this is the command that tells the router to be looking at the packets that are coming in to investigate whether or not a network address translation needs to take place. So let's go ahead and end this. Let's say write mem, and let's say show run. Oops, sorry, show run. And we should see right down here, there is our IPNAT inside source static statement. Super straightforward. The easiest of the NATs to configure. Let's open the command prompt back on PC1. Let's come back over here and see, can we open up, and first I guess they want us to try to ping. So can we ping? But the question is, what address are you trying to ping? Remember, if I try to ping the 172.16.16.1 address of the server, I'm getting a reply back that says destination host unreachable. And probably because the internet has no route to get there, right? Because that's a private RFC 1918 address. But if I try to ping the publicly routable address, right, which is the 64.150.1, that address is reachable via the public internet. Now, we may have an ARP packet and get a request timeout, but all of the subsequent packets should work. If I ran the command immediately, we're going to see that the ARP cache still has the information for me to get there. And so we have full connectivity. Now it says verify that they can access the web page. They want us to use the laptop as well. I think we're probably just good here with http://64.100.50.1 and welcome to server 1, right? If I was to pull the laptop up, maybe we do a quick ping test. If I can ping it, I'll be able to get the web page 64.100.50.1. And there we go. And so it looks good for both PC 1 and laptop 1. But let's get back onto router 1. We have some interesting information now in the translations table, right? And so down here at the very bottom, there is the static entry. This is the result of the static entry. There's no protocol, right? It's just statically here in the NAT translation table because by definition, if it's statically defined, it will statically be in the translation table. But we've got all of this other information here, and you can see the latest TCP protocol, and that was going to port 80. And again, this is from router 1's perspective. So the inside global and inside local, right? There's our definitions for this router. You can see we've got the ICMP protocol being used here, and then we've got the outside local and the outside global. Remember, these are not going to be different in 99.9% of the scenarios, because how I see, right, and when I say I, how server 1 sees the host that's pinging it, PC1, it's going to see it as everybody would see it outside of this NAT boundary, right? Outside of, this so here's the inside of the network from server 1's perspective, and then outside, how is it going to be seen? Well, locally and globally, unless it's being double natted, it's going to be seen as 209.165.201.1, as that's where it's coming from. And so that's where we see the translations. A new command here, show IPNAT statistics, is going to show me the total number of translations, right? Static versus dynamic, excuse me, the number of hits, the number of misses, and expired translations, right? No dynamic mappings here to speak of, but this is what we've got set up right now in terms of static NAT, and that, as you can see, got us to the completion of 100%. All right, well, this is one of the easier labs that we're going to be doing, one of the shorter labs we're going to be doing. Let me clear the screen here of the typing. And so that is going to do it for this packet tracer tutorial on activity 6.4.5, where we took a look at configuring static NAT. Remember, it is a strictly one-to-one relationship, an inside local IP inextricably linked to a single inside global IP. All right. Thank you so much for watching. All the best to you in your studies, and I hope to see you in the next video.